Hello everybody, Thy Lord Root here, and welcome back to another Unity tutorial. Now we did Pong last time, and we left with quite a few warts on our project, one of them at least completely apparent. And we're going to work on improving our game today, because I figured, we might as well have this. But before we do that, I do want to do a little bit of housekeeping. So I'm going to delete this materials folder here first of all because it's a duplicate material that we don't really need. And I'm going to drag the center line to this. I'm also, for the purposes of our development, I'm going to mute our sound until the very end. And the reason for this is because, as you may have figured out in developing some of these games already, having the sound go constantly can get very annoying, and it will be quite an issue. It can make you very irate. Another thing I'm going to do here is I'm going to rename this just to Game. That's just more for consistency more than anything. And then we plan to create another scene, so I'm going to start thinking ahead to that. I'm going to move these guys into a script called Game here. And while I'm at it, I'm going to move, or rather a folder called Game. I'm going to open up our ball controller, which is what we will need here in a bit. Well, there we go. So let's sort of think about what we're doing real quick. First of all, we have one outstanding issue that we have to think about. Right now, the ball goes off in all sorts of directions, as you can see. And that's not really desirable. There's actually a reason for this. It's something that, in reality, I should have thought about. However, I can't entirely be blamed for it because the issue is that the degree measure, or the angle measure, is inconsistent in Unity. So you go up here, you see that we have these guys in degree measure, which is what everybody's used to. Now there is another measure that's very popular in math because I'm just going to, real quickly, I'm going to turn on the grid so that we can sort of get ourselves a decent unit circle going. And let's talk about another measure called Radian Measure. So we have this unit circle here. And in this unit circle, we have a radius, which is radius 1. And we just happen to know here that we have a circumference, if you've taken geometry, that is equal to pi times d. Well, our diameter is twice our radius. Therefore, for the unit circle, the circumference is 2 pi. Now, knowing this, let's say that we want to find the arc length of this guy right here. Let's say we have a sector here, and this is an angle which, why don't we call it T? Then that arc length is going to more or less be a function of that. So to figure out that angle there, we need to basically do some conversion here, because if we have 180 degrees, then we have pi here for the length of this arc. And if we have 360 degrees or 0 degrees, that's equal to 2 pi. So what we can do now is we could say that we have our angle in radians is going to be equal to our angle in degrees times pi. And then there's 180 degrees in a half circle. Likewise, we could also say something to the effect of t is equal to a times 180 divided by pi. It turns out there's some very nice properties to this, but the two yield two completely different numbers. And so it's important that we have this. So let's address this issue here. I'm just going to go to our code and we will update this. So 45 degrees, if you do the math on it, is equivalent to mathf.pi divided by 4. That is Unity's approximation of pi. As you may know, pi is a transcendental number, and therefore, it has this issue to where, like, because it's non-repeating and non-terminating, it's also irrational. And there's limited, there's just limited sort of accuracy to it, limited sort of precision. So we've got, the two aren't the same, by the way, but, you have to approximate this, and that's Unity's best effort for approximating it. We also have 3 times mathf.pi, also divided by 4 for 135 degrees. Now, if we go ahead and play our game, what this is going to do is this is going to always launch the ball towards player 2, and that is probably not desirable in a game. That shows, at the very least, like some kind of favoritism, and nobody likes, playing favorites. But it also means that the likelihood that the game would be fair might be in question as well. So we're just going to do a little trick here. We're going to randomly invert the angle of the ball. And the way we can do that is we could say if random.value is less than 0.5, because if I'm not mistaken, this guy is constrained between 0 and 1. And so this gives you a more or less uniform distribution for this. And you can just say angle is equal to negative angle. That's, of course, assuming that random.value also has a uniform distribution, which in many cases, and if you're talking about random number generators for computers, that's usually the case. I could go on and on about things like period of a random number generator and its uniformity and stuff like that, but I'm not going to go into it this episode, so consider yourself spared. But if we change the style, we have to say is something to the effect of, randomly point at one of the players. You could come up with other rules for this. Maybe the ball points towards the winning player, because this actually, to some degree, depending on the position of the player, it could make it a lot harder for them to actually reach their goal. So, yeah, that's one deal here. If we try this out, then we will see that, yeah, there we go. Again, it's worth pointing out that this is not, in the sense that, like, this probability is uniform in the sense that, like, if you took an infinite number of tries here, it would roughly be the same in both cases. So there we go. What we're interested in doing now is figuring out how to address this issue of properly hitting the ball, because what we're doing right now is we're determining where we should be based on the ball's current position. There's a joke in Futurama about this, that, you want to, when you're killing the last space invader, you want to be under where the the Space Invader is going to be, not where it is now. And the same is true here, because we're really going out of our way, and because the velocity can change quite easily by reflecting off of the walls, then we have this issue to where we really want to meet up with the ball where it's going to be. Let's see what this guy is doing now. This is a little debugging tool that's a little bit more reliable than the console, because the console is getting updated every frame. And we don't really want that. I'm going to create a new quad here. And I'm going to temporarily turn off the mesh renderer. This quad is going to be called our indicator, in the sense that it indicates where our paddle wants to be. And now if we click on this guy, you can see that we can't see it. I'm just going to flip it around by 270 degrees. I'm going to raise it slightly. Oddly enough, using the x-axis, because of the fact that we're rotated now, so x is all of a sudden up. We want to do two things. Let's get rid of this mesh collider first of all. It's not really worth having around as such. And the other thing to do here, in addition to this, is that we want to create a material for it, because this guy is not really that easy to look at. So I'm going to create a new material here that we will call the indicator material. And so the deal with the indicator material is that we're going to have a texture on it, but we don't want to use the shader. You see, if we just use this as is, the Unity itself doesn't know what to do with the alpha channel, and so it creates a checkerboard pattern because there's full alpha on there. That is not really desirable. It'll block a lot of things. So we could just go over here to the transparent shader and use transparent diffuse. And then I'm going to make it red so it's a little bit easier to see. Now, we have a few things that we want to do here as well. This indicator needs a rigid body, and so I'm going to add that. This is not only not going to use gravity, but it's going to be kinematic. And because we have no collision mesh on it, nothing can really, whether it's kinematic or not, it doesn't matter. But it's good for us to go ahead and set it as kinematic. And I'm going to go to our player script here. I'm going to do a couple of things. The first is, while I'm here, I'm going to go ahead and make the level width and the level height constants, public constants in fact. That level height is about 4.5 for that center line, the boundary where the player can interact. And then, in addition to that, I'm going to create a public transform called indicator. Now, why a transform? Well, you see, you might think, okay, well, we need to pass in the game object, but Unity is smart enough for us to be able to determine where, from the fact that we have a rigid body on our Unity object, or on our game object rather, that it also has a transform, and it'll propagate it. So we'll have public void set indicator. We'll pass in a floating point value, and then we are going to do a couple of things. We're going to say vector3 position is equal to indicator.position. We're going to say position x is going to be equal to mathf.clamp x, and then negative level width and level width for the bounds. We're doing this so that we do not go out of bounds with the indicator. And then, of course, indicator.position is equal to our temporary position. Again, like we mentioned last time, we have this issue to where the you can't really directly mutate these from the indicator position field because it would create a this position is created as a temporary, and so we can't really directly reference that. And it's probably likely because of the fact I bet you that this vector 3 is a structure. Yep. So C Sharp has a number of ways of dealing with structures. They don't exist primarily on the heap. They exist where they are declared. So in this case, this vector is on the stack. Well, before I get too much into that, let's go back to our game controller here. I'm going to remove this guy because we already know where this dude is, or which one we would have in this case. And I'm going to say p set indicator to x. This function is relative to the center of our paddle. And so we want to make sure we subtract out the ball's position. And then we can replace all of this with another clamp. So we'll say clamp x -1 and 1, and that's pretty much the same thing. So what we'll say here now is set indicator to our prediction. Now there are some things that we will want to do to the ball controller in order for us to be able to make a better prediction, but let's go ahead and turn on this mesh renderer real quick. Let's drag our indicator to its new slot, and let's apply this. And now you can see, we're making our prediction here, and that's okay, I guess. But it's not really what we want. You can see it's all over the place. So what we're going to do instead is we're going to calculate our predicted position based on the ball's heading. And so what we're going to do for that is create a public float called predict crossing. And in that case, we will say that we have some value here that will return 0 for now, because we really need to think about this. I'm going to go ahead and comment this guy out, and I'm going to say instead that float.bx is equal to ball predict crossing. Now we need to make this generic for both of the balls, and that's not all that hard to do. So what we can do here is we can bring Inkscape back up, and let's say that this guy is our ball. In fact, I'm going to make it 4x4 here so that we can easily see our vectors here. Our border here, our boundary, is up here. And why is it not doing that? There we go. And we have a velocity vector associated with this ball, that if no force acts on the ball, then it'll move over like so. And I'll just indicate that with a vector arrow here. So in markers, we'll go here. Likewise, we have a unit vector pointing up to this guy as well. And now we have something like, oh, don't do that. We'll just have our velocity v here and our unit vector u, like so. Now, one way you could go about this is that you can calculate this angle here using the arctangent function. You could do a trigonometric solution to where you can say, well, I've got this guy up here, and this is, I basically want to find the x-coordinate of this point, and that is doable. But that is not really what we want to do, and the reason for that is that we have a much better solution here, and I will show you exactly how that works. Let's instead say that with our velocity, that within one time unit, we would end up here. I know that's a little bit hard to see, but I'll just move this guy over here like that. And we want to know our height at this position. And from that, we can calculate the amount of time that it takes for this guy to get up here, or in general, up here. So let's talk about how we might do that. I have up here my position equation that I'm going to put in. So let's say we want to hit x prime. We'll say x prime is equal to our initial x sub naught, and then that's plus our velocity times our time. We have no acceleration on this because no force is being applied to it, but you will recognize that this is the first integral of velocity with respect to time if you've taken a calculus class. This is, incidentally, velocity is also the first derivative, and so we can solve for t this way. And the way we would do that is we would say that x prime minus our initial x divided by our velocity is equal to t. It's that simple. And then we would want to take this t and then plug it back into our equation for our x here. So let's go ahead and do that. I'm just going to go back to our ball here, and I'm going to grab a few things. We want a vector 3 that represents our position here. We also want one that represents our velocity. And what we're going to do is if you look back at our deal here, we're going to calculate this magnitude right here. And because we're dealing with a unit vector, that's quite easy to calculate here. What we'll say is that, first of all, we have already our target, right? So float target is going to be equal to our player controller times our level height for 1/2 of the field, and then we want to actually make this level height relative to the direction we're traveling. So I'm going to use something called the Ternary Operator to make that happen. I'm basically going to say if velocity z is less than 0, then multiply that by -1, otherwise multiply that by 1. This can be very useful for compact equations where you have these piecewise, the piecewise equations like that. And then finally, we want to calculate our time. Let's plug everything in. We have x prime, and we have our initial position. We also have our velocity for that position there. So what we're going to do is calculate the time to target and determine target height. Now all we have to do here is go back in and substitute everything. We don't know quite yet what x prime is. That's what we're trying to determine. And so what we can do is we can say now that we have our x position plus our velocity, the x component particularly of our velocity, times our time. And that actually gets rid of the need for trigonometry here. So I think I should, well, let me run this first to show you that it does in fact work. That these guys are now moving where they think the ball is going to be. And in fact, I'm going to go to the game controller and turn off human control on the first paddle. And you can see that, oh, that's sort of a bad example. Oh, come on, give us a better velocity here. Yeah, there we go. Why it's doing that, I have no idea. Perhaps... There we go. You might tweak those angles, incidentally, but you can see that right now it's doing a fairly good job at its prediction, and these guys are evenly matched. Despite the fact that the ball is behind them, they are moving ahead to meet up with the ball. Okay, so let me go ahead. I'm going to disable this indicator, or at least disable the renderer for it, and hit apply. And I'm going to talk briefly about why we want to avoid trigonometry in this situation. Now, in this case, we needed it because what we're trying to do is we're trying to figure out, you know, given an angle, what our velocity vector should be to maintain a constant velocity. And we only really call this once the ball's reset. There's no real major penalty for it. However, trigonometry in general is very expensive for the computer to do. There are coprocessors that help with it, but the thing is that some of the approximations that we have, like, so generally what you would do is you would do something called a Taylor series on those functions, and you get a number of additions and subtractions, and that would help you, you know, get a decent approximation, because at some point we know that floating point numbers have limited precision anyhow, so an approximation, pardon me, is just fine. But if we were to do this trigonometry all the time, like once per frame, and we're actually doing it more than once per frame, we're doing it twice per frame in this case, that could really slow down the game. And so we want to avoid that. Now, with modern computers, it doesn't slow it down as much. You know, back in the day when, you know, there was, like, for instance, you could get a 286 clocked at, I think, 4 megahertz was one of the common clock rates of that, and, you know, you had more than one clock per instruction. It really mattered. But these things stack up. I mean, part of the thing you want to do as a game developer is you want to isolate where you've got these bottlenecks in your game, and you want to optimize them. Now, you don't want to do what's called premature optimization. You don't want to optimize meaningless parts of this. So, for instance, we didn't optimize reset because there was no need to. It gets called every once in a blue moon. But this predict crossing is a hotspot here. And so, incidentally, we ended up with a, method of calculating this that was not only easier for us to calculate, but less computationally expensive and easier to follow. So that is pretty much my rambling on that. Now I want to move to another goal here. I'm going to save this guy, and I am going to create a new scene. This scene is going to be our menu. I'm just going to go here and do a couple of things. I'm going to go to scenes, call this main menu. And what we will do here is we'll create a game controller. Specifically, we'll call this the menu controller. It doesn't really have to, you can call it whatever you want, but good names are important. Let's do this. You can tag it if you want. We're not really going to need tags, but we might as well. I'm going to attach a script to it called menu controller here. Now, I want to be absolutely clear about something. We have just done something right now that could cause us issues in the future. For instance, what if you want a menu in the game as well? Well, fortunately, there's something called namespacing that we can use for that. I'm going to create a new folder called MainMenu. Here, I'm going to drag this guy up here. And why don't we edit that script just a little bit? What we can do here is simply open monodevelop, and there's this thing called namespacing. Now, namespaces are sort of like packages in Java. If you've used C++, you're familiar with them. Basically, the idea is that there's a one-to-one mapping between each symbol. The compiler has to know what it is, otherwise it's ambiguous, and it can't really do much from that. And namespacing is a way around this. So we're going to call this namespace main menu. And we're going to just quickly, by doing tab here, we're going to tab this guy in. And we're just going to drag these guys over here. Now, if we have a main menu in our game, we could put this maybe in a game namespace. Now, for the sake of brevity, I haven't gone through and renamespaced everything in the game folder. From now on, I will be putting everything in the same namespace. But there's a couple of things you can do here. You can refer to this guy by its fully qualified name. So I could say mainMenu.MenuController to refer directly to the menu controller. I can also say here, maybe in the small controller for instance, where we're clearly not in the menu controller or the main menu namespace, I can import the entire namespace by saying using main menu, and that'll bring in the entire namespace for that object. But we can also, we don't really have anything else here, but we can just refer to this by its unqualified name, which is without the namespace name attached to it. We can say menu controller here, and because we're within the main menu interface, then that'll work. Now, it would be very good for us to go ahead and create our canvas, but let's do some things first of all. We need to go ahead and put this guy in such a way that, we actually have a defined level order in our game. And we will do that briefly by going to the build settings. And so you can see up here scenes and build. We can hit add current. And this is now the first scene in the build. This is the scene that will load as soon as you start the game. I'm briefly going to go to this game here, this game scene, and I'm going to attach it as well. And I want you to notice there are numbers over here. These numbers, just like for the arrays, are zero based, so 0 is the first scene. And they provide a convenient description here of how you could get back to the game, right? You can get back to a certain, not a convenient description, but a convenient handle rather, of how to get back to the scene. So, how do we interact with scenes anyway? Well, first of all, let me go ahead and talk about how we interact with the GUI. First of all, we'll create a canvas, and we can go into 2D mode if we'd like, or we can go into game mode here. I'm going to insert a new thing called a panel. A panel basically contains other user interface controls. I'm going to make this one 300 by 300 maybe. That seems like a good height for it. I'm going to put it in the center of the screen. We'll call this the main menu. And we're going to add some buttons to it. Now, one of the first things you want to do is add a title as well. And let's talk a little bit about human-computer interaction while we're at it. You see, human-computer interaction is the study of how user interfaces apply to computers. And so, you want to make your user interface, however you do it, you want to make it as easy to use as you possibly can. Now, this is a big engineering issue. This doesn't just apply to computers. There's a book on it called The Design of Everyday Things by Donald Norman, and he talks about a lot of really interesting real-life analogs that you might find useful here. Let me just set the size to 24 here. We'll set this to Pong, and we'll put the title up at the top, where it's easily readable. He talks about, within the first few chapters, things from, just like, for instance, how the design of stoves have changed over the years. So if you grew up with an older stove, they were arranged, the burner controls were arranged in a grid-like pattern. And through some very clever engineering, they rearranged the controls to where they easily mapped to the burners on the stove and made it less likely for you to burn your house down. In particular, we want to talk about maybe affordances. So basically the idea is if you have a button that affords pushing, and we'll just do, we'll name these guys real quick. The button has a label on it that, we'll say one player game. And the idea is that by pushing this button, the idea would be you would start a one player game. Now, I'm going to duplicate these here in a bit, because I'm going to attach a listener to this. These buttons fire events using something called the observer pattern. So the idea is that you have these objects that are designed to listen. If you click on this guy and bring up the menu controller here, then you get that. And we're not going to set the callback just yet. We're just going to prototype this thing. But the idea, of course, is that when we duplicate this thing, we won't have to go through the hassle of, let me just duplicate this twice because we're going to do some other things here. Two-player game. Really, we want to think about what the player might want to do here. So, of course, the player would want to start a one-player game, and they might want to do a two-player game. It's conceivable that they want to see the CPUs fight against each other, so we're going to call this guy CPU versus CPU. And we'll change that in the text as well. And then this is an important one here. As it currently stands, there's no way for the player to quit the application. And we really do want that ability, because otherwise they'd have to force quit the game using like the three-finger salute. And that is not very friendly. That will make your users irritated, to say the least. And I'm just going to arrange these guys so that, they're not colliding with each other. These guys are rendered in the order that they are in the hierarchy, so we just want to move these guys out of the way. And so right now, we have this button, and we can push it, but it doesn't at all afford what we want it to. And so what we can do there is we want to create these callbacks. Now, just some things about this. These can, first of all, be public functions, right? So we're going to call this on one player. And we can very easily prototype this. We have two things going on. We want to set the player configuration, and we also want to load the game level. So the way that we can do that is we can say application.load level. However, getting this player configuration set up is a bit of an issue because of the fact that we do not yet, in fact, the game controller in the game scene has not been created yet. And this is a bit of a problem, you see. So I'm going to go to this game controller script. I'm going to use a brand new keyword here called static. We may have used it in the past, but we're going to have the static variable here, and basically the idea is that this belongs to the class rather than a specific instance of the class now, which allows us to do something like this. We can say something sort of like game controller dot player 1 is human is equal to true. That's true for one player, and then also player 2 is human is equal to false. And that would cover us. We could also copy this code here and do CPU versus CPU. Now, when this class is loaded, these guys are both set to false. That's just the way that C# works. So you might be thinking, okay, well I can, and I guess we have to put the level index there too. You might be thinking, I can take this out, and I can get my CPU versus CPU. Now, if we assign our callbacks, which I will show you how to do momentarily, all I have to go down here and do is click on No Function, then click on Menu Controller and on CPU versus CPU. Same for the one player. And let's see if this actually works. Well, actually, we need to do one thing before we do that. We can actually go to the game controller. We need a way to back out. of the game. And so what I'm going to do that, or what I'm going to do there is I'm going to put in an update function, and I'm going to intercept a button press called cancel that is mapped to our escape key at the moment. So we'll say input get button down cancel, and then we will say something along the lines of application load level, and then we'll just go back to level 0 like this. Did we do that in the... Yeah, we put the right levels there. Let's go ahead now, go back to Unity, and try this. Now, of course, player 2 and quit won't do anything because they're not mapped to any callbacks. But we can hit CPU momentarily, and you can see that at first blush this is working just like we want it to, right? We've got these guys here, you know, they're playing against each other, and we don't have any user control. But let's go back to this one-player game. This works as intended, and we could go back to the sky and see that no matter how many times we hit this button, we've got a one-player game no matter what. But let's go back to CPU versus CPU. Uh-oh. This is now a one-player game, and there's actually a very good reason for this. If we go back to this game controller here and look at these two variables, these guys last for the duration of the program, so they are set, and then nothing comes around to change them. And so by us going through and setting it once, we've now basically, when we go back to this menu controller, this guy is depending on an undefined state, and we want to get around that. That means we have to have this guy here. But just copying and pasting these guys for all of the levels is not really that good of an idea. And the reason is that we might have to make changes to this in the future. So we're going to create a private function called loadGame. And we're going to take two parameters for that. We're going to take a boolean for whether or not the player 1 is human, and another one for whether or not player 2 is human as well. We're going to copy this code up here into that. And now we can just make some minor tweaks. So player 1 is human, will be set there, and player 2 is human will be set there. Now all we have to do is say load game, and is player 1 human in a one-player game? Yes. Is player 1 human in a two-player game? No. Likewise, we can create the remainder of our callbacks here. And so in this case we want this guy to be true, because in a two-player game the second player is a human. And then finally we'll say load game false false for our CPU versus CPU. Note that we've left one option out. That option in particular is the option of the second player to fight the CPU. Now, we could conceivably put it in there, but that's an option that the player is unlikely to want. It's hard for me to really think of much of a reason to do it. And so that's something called a don't care condition. We'll never encounter that condition, so we might as well not think about it. Whether or not we can do it is immaterial. Let's add one more callback here, and we'll call this onQuit. And you might be asking, okay, we can assign these callbacks here, but how do we make this callback afford quitting? Well, conveniently, there's something called application.quit that we can use, and that will just terminate the application without notification, by the way. So I'm not going to show you here how to do that for time reasons. That may be in another tutorial, but that will work for us. Although there's a caveat there. Let's go real quick and assign the rest of our callbacks. If we go to our two-player guy here, we'll do menu controller on 2P and quit on quit. Let's just save this guy here so that we don't lose all of our progress in the rare event that my computer shuts down. It's been complaining about my battery lately. You can probably see that in the corner. But now, let's do some testing. So let's do a one-player game. That seems to work just fine. Let's go here and do our two-player game. I'm not very good at doing two paddles at once, but yeah, I mean, that seems to work. This is where our bug was. Do we have CPU versus CPU now that those two static variables have been clobbered? Indeed we do. And so that's very useful to us. But I want you to notice that when we click quit, it does nothing. Now, we did tell the application to quit. But if we were to do this while we were in the editor, then it would probably shut down Unity and nobody would like that. So the editor intercepts that quit message and just prevents it from happening. Which means that if we're at this point to where the only real thing that's not working is quit, maybe what we should do is we should make our game ready for publication. So I'm going to unmute these sounds because in the final version of the game we do want these sounds available, and I'm just going to test this scene to make sure that it works. Indeed it does. So now we need to go to build settings, and I want to talk a little bit about your build platforms. You can see here that we have a ton of different options available. The one you're most likely going to be interested in is PC, Mac, and Linux standalone. And here you have a number of options. This guy is okay here if you want to support more than 4 gigabytes of memory. Then x86-64 is the 64-bit Intel. Almost every PC supports that now. You might find some computers out there that don't. And you have these options here, like for Windows OS 10 and Linux, that will be useful as well. If you're trying to sell this game, it's worthwhile to build 3 different deals for it, the 3 different binaries for it, and that will allow you to more or less, target, kill 3 birds in 1 stone, as it were. Alternately, you can make this game available via the web player, which I haven't messed around with. I believe that this either uses HTML5 Canvas or Flash. I don't know too much about this. You can target the 4 major phone platforms out there. So iOS is for the iPhone, and also for the newer iPods and the iPad as well. Android, of course, is for your Android phones. This is definitely worth considering if your game can fit within that. So, if you're doing a real physics intensive game like maybe Kerbal Space Program, the chances of getting this onto a phone to where it would be reliable is not really all that good. You have the BlackBerry, which is probably the least supported major phone that you can get. Used to be popular a long time ago, but nowadays Android is replacing it. I've seen a few people with Blackberries. They've come down in price, so I mean it's affordable. And then you have the Windows Store and the Windows Phone here. And that, of course, requires Windows 8, which I do not have and do not plan on updating to. You'll notice some grayed out options here as well. If you buy the Pro Edition of Unity, which is like $1,500, you can target consoles as well. Now, a lot of you don't have $1,500 just laying around, and on top of that, you might want the development version of the console as well. I'm not sure if it applies to these guys here, but it might be kind of useful. PlayStation Mobile is free, and I'm not entirely sure what that is. But I do want to point out, and I will put a link to this in the description, that Nintendo has opened up their development program. So it used to be around the time of the Wii that you paid $2,000 and you needed a good portfolio, and you would get the Wii SDK and the entire tool chain and stuff like that. And that makes it difficult for indie developers to get involved. Well, Nintendo realized early on, they had their virtual console and their WiiWare. And having all these indie developers being able to program against that sort of set the tone for all of these other developers here. So Microsoft had something very similar. They had a free tool chain called XNA Studio. I don't believe that has been kept up to date. I think that is deprecated as of the Xbox One. And of course the PS3 tool chain, last I checked several years ago, was like $20,000. But this guy you can get for free. So if you have a Wii U, I haven't tried this because I haven't purchased the Wii U myself. I keep on telling myself that I'll get myself one of these days. But there's Unity for it. I believe that the sign up for the program is free, and that they've been working with the Unity people rather, to make it freely available. The main thing, of course, is that with this you get another annoying feature without paying the licensing. And I will show that off now. We'll just build and run this guy. I'm going to call this Pong.exe. And it's going through compiling all of our scenes right now. And you'll get a window like this that may be rather annoying to you. I'm running it at 800 by 600 so that in a windowed mode here, I have a decent video card for a laptop, so I'm going to set this to beautiful. And then you can see we have our input mappings over here, and our new axis has been mapped to it. And you got the splash screen that always comes with the free version of Unity. And if you're a professional game developer, that may make the $1,500 worth it just for that alone. I think it's worth pointing out that, a lot of people might be like, okay, well, I'm just a small-time indie developer. How am I going to sell my game? And there's a number of ways to approach that. I'll talk about that here in a bit, but first of all, let's see if this thing works, because you can't sell a game that does not work. And of course we have player 2 here. And then CPU versus CPU works as well. More importantly, does our quit button work? And indeed it does. So now I want to talk a little bit about maybe funding your game so that you could get the newer version of the pro version of Unity. If you have a game that everybody seems to like, there are people out there who are willing to pay for it, or they might be willing to do a Kickstarter. So for instance, I just saw a game called Shovel Knight that used a Kickstarter, I believe, to get the game going, to get it funded. The most popular instance of this is something called Star Citizen, which, as far as I am aware, has the highest record on Kickstarter for raising funds. It was like 47 million last time I looked. It's probably a bit higher now. Now the problem is, though, unless you're well known as a game developer, this, you could either use early access or the Kickstarter to do this, but you have to have something worth playing as a result. So now I want to talk to you about whether or not this game could possibly fund this sort of thing. I don't really think so. I think that everybody is used to, the bare bones features of Pong. Certainly, Pong is one of the first projects that anybody does in a game. And so, if you were going to do Pong, you'd want to offer more than this. In general, you want to avoid shovelware. Shovelware being software that you just publish for the guise of just making money, that you don't care whether or not it's good. This has caused the game markets to crash in more than one instance. Notably, since we're speaking about Pong, which is known for being on the Atari, although I believe that the Magnavox Odyssey was the one that introduced it. There was actually a point in 1983 where video games were so terrible to where there was so much shovelware that these games just, nobody bought them. They weren't really, there was no quality control on them. You'd have games that certainly were not fit for children, and nobody warned these people, by the way. I mean, it's, games with like tons of nudity, which, okay, it isn't a big deal if you're an adult, right? I mean, some people go for that sort of game. But, games like that, were targeting that sector of the market, and parents didn't know, so they buy their children these games. Now we at least have the rating system in place, which I think has been good for, getting parents who, to be fair, have to be aware of what the ratings are. So, I mean, it's debatable whether it's actually changed anything or not. You still got parents buying their 9-year-old children games like Grand Theft Auto, which is questionable. But then, you also have things like, E.T. was the worst offender of this. Now, I actually have 2 copies of E.T. on my Atari that I got for, I don't know, like, I got the, Atari itself plus like tons of games for $50 at a garage sale. And my friend and I were like, yay, we got 2 copies of ET. And the seller just gave us this exasperated look and asked us, that game's terrible, why do you want it? To make a long story short, you do not want this reputation for your game. So this is something to think about. If you do use this sort of model, make sure that you have a fair amount of polish in your game, that even early on that it's fine. And, listen to your users. And you know what? You never know. They may be saying, hey, I like what you're doing, I'm more than happy to pay for this game. Be reasonable about your pricing, by the way. Don't make, a game that's an early alpha. Don't make it like $20. It's not worth it. It does everybody else, including yourself, an injustice. And it makes people unwilling to buy games. But, use reason there. And I suppose for the time being, I will go ahead and leave it here. Until then, this has been Thylord Root, and I will see you later.